Hello ladies! Okay, today we are going to be walking through the periodic table. I'm going to be introducing you to the different families and groups of the periodic table, how we label them, and what's important that you need to know about each of them. Okay, so just to start us off here, so this looks just like the periodic table that you should have in front of you right now. So just a little bit of review. Remember what we talked about last class, how when you look side to side, we call those periods. So the rows of the periodic table, we call them periods. And remember that in this periodic table, we have 7 periods, right? 1, 2, 3, 4, 5, 6, 7. These 7 periods tell you how many electron shells surround the atom. So for instance, sodium right here. Sodium is in period 1, 2, 3. There are 3 shells of electrons that surround it. The shells being the 2, 8, 8, 16, 16, 16, etc. So 1, 2, 3. The third period has 3 shells. Oxygen's in the second period, 1, 2. Therefore it has 2 shells. Lead here is in the 1, 2, 3, 4, 5, 6th period. So it has 6 electron shells surrounding it. So again, we call the rows on the periodic table, the stuff that goes this way, periods. Now going up and down, we have families or groups. So for instance, family 1A, family 2A, family 7A. These tell you the number of valence electrons in the final shell of the atom. So remember that valence electrons are the electrons that are in the very most outer shell of the atom. So for instance, let's do aluminum right here. Aluminum is in period 1, 2, 3. So it has 3 shells. In that third shell, there are 3 valence electrons. Let's do magnesium. Magnesium is also in 1, 2, 3, the third period. So there's 3 shells. In that final shell, though, there's only 2 electrons. Let's see, neon is in period 2. There's 2 shells, but it has 8 or a full valence shell here. So again, family or groups go up and down. They tell you the number of final electrons in that final outer shell. Periods go side to side, and they tell you how many shells surround the atom. So a little review there for you. You can feel free to write that on your periodic table anywhere you want. Okay, so here's what else you're going to need to write on there. I just drew this little line that goes down here. It starts in the upper left-hand corner of boron. It goes down, over, down, over, down, over, down, over, etc., all the way down. This little stair-step line tells us the difference between our metals and our non-metals. So looking at our periodic table, anything that's to the left of this little line is going to be considered a metal. Now, our metals have properties of being shiny, they conduct electricity very well, they can be hammered into sheets or drawn into wires. This is the property of metals. Everything on this side of the table is considered a metal with the exception of hydrogen. Hydrogen is kind of weird, and we'll talk about that more later. Non-metals are everything to the right of this stair step. So everything here on the right side of this little stair step line is considered a non-metal. So first of all, feel free to draw this in. Draw this in like a nice dark color so you're able to get kind of the really strong visual representation of this line. It's going to be helpful to you later. And then if you kind of want to draw something like this, maybe that shows like metals being over here, you don't need to color any of this in yet, but just kind of indicate that these are all metals, these are all your non-metals. So that's the first stage. Okay, so the first thing to color. So grab a color, anything you want. Now make sure you're just kind of lightly shading because I want you to still be able to read the periodic table after you're done, but this is just to kind of help you keep things straight. So you are going to color in 3B through 12B, this whole section here, just kind of lightly shade this in. You'll also be shading in these guys down here because these plug in right here, so they're all technically one group together. Now this group, going from 3B all the way over to 12B and including the lanthanides and actinides, are called transition metals. We also call these B group elements. Now, we're not going to talk about the transition metals too much because they're kind of weird and they don't follow the nice patterns and trends that the rest of the elements do. You'll notice that all of these guys stick up a little bit. They're called A group elements, including these. These B group elements or transition metals follow some kind of strange patterns, and so we're not going to really deal with them too much, but lightly kind of shade this in, 3B through 12B, including lanthanides and actinides. Make them all the same color. But we're really not going to deal with them too much. So a lot of the patterns we're going to talk about today don't apply to transition metals. So again, feel free to pause me at any point and just do what you need to and then move on when you're ready. Okay, so your transition metals. The next thing you're going to do is you're going to color lithium, sodium, potassium, rubidium, cesium, and francium. This whole group here, pick another color and just kind of lightly shade those. These are called the alkali metals. They are metals, lithium through francium, not including hydrogen. If you look back, I didn't color hydrogen on purpose, and we'll come back to why that is. These all have 1 valence electrons in the outermost shell. So they're called alkali metals, and they all have 1 valence electron in the outermost shell. And again, we know that because it's in group 1A. So they have 1 valence electron. Okay, the next group. So again, transition metals, alkali metals. This group, 2A, you're coloring beryllium through radium. These are called your alkaline earth metals. They are metals, and they have 2 valence electrons in the outermost shell. So again, transition metals, alkaline earth metals. Next group. This is group 3A, boron through UUT, whatever UUT is. There is no fancy name for this group. We just call them group 3A. All elements in this have 3 valence electrons in the outermost shell of the element, which is important. Again, so transition metals, alkali metals, alkaline earth metals, group 3A, group 4A. Group 4A does not have a fancy name. It's carbon through whatever FL is. I don't know what that is. There's no fancy name for this group as well, and they all have 4 valence electrons in the outermost shell of the element. So we have transition metals, alkaline earth metals, 3A, 4A, and 5A. Nitrogen through UUP. Again, a lot of these don't have names yet because they're yet to be fully identified. All elements in this group have 5 valence electrons, again, because they are in group 5A, so they will have 5 valence electrons, just like 4A has 4, 3A has 3. Okay. So we have transition metals, alkaline earth metals, 3A, 4A, 5A, and then 6A. These are our chalogens. Oxygen through LV. All of these elements have 6 valence electrons in the outermost shell of the element. So again, all of these are just kind of lightly shading in different colors so you can tell them apart, just identifying these different families. Again, please make sure you can actually still read all of the information on here because it won't be helpful to you if you can't actually read each box. Okay, moving on. So we have transition metals, alkaline earth metals, 3A, 4A, 5A, 6A chalogens, 7A halogens. Halogens are fluorine through UUS, and this is, again, we're getting into the non-metals here. All of the elements that are halogens have 7 valence electrons in the outermost shell of the element. So these guys have 3, 4, 5, 6, and 7 valence electrons right here. Okay, so we have transition metals, alkaline earth, 3A, 4A, 5A, 6A, 7A, halogens, 8A, the noble gases. Helium through UUO. All of these elements have a full outer valence shell. So they have 8 up here, and that'll certainly apply when they're in rows that have 8 in their final shell. When you get down here, 8's not necessarily true. It's just saying that it has a full valence shell. These guys cannot accept any more electrons, which we'll talk about a little bit later today when we talk about ions. Okay, so last but not least, we have our transition metals, alkaline earth, 3A, 4A, 5A, 6A, 7A, 8A, and then hydrogen. Last but not least, hydrogen is going to be separate from all of these. So pick a color you haven't used yet and then lightly shade this hydrogen. Hydrogen is a metal. It's on the metal side of the periodic table, but it's not. It's actually a gas at room temperature, and it does have 1 valence electron in the outer shell, just like the rest of the alkali metals or the group 1A, but it kind of does its own thing, and it's a little bit strange and separate. So we color it separately and distinctly from the alkali metals just because it does different things and because it is gas at room temperature. All of these solids, so everything to the right of this section, to the left of this section of the periodic table, are metals. And so they're solid at room temperature, they're shiny, they're ductile, they're malleable. Everything to the right is usually a gas at room temperature, and it's dull, it can't conduct electricity, so they have specific properties. And because hydrogen is such a departure from the rest of the metals, we do color it separately because it's not an alkali metal. So that's the periodic table. So again, you've drawn in your little line here. You've indicated that these are metals, these are non-metals. You've labeled each of these columns that we've colored, not only the name, but their number of valence electrons. And that should be it. Let me know if you guys have any questions. Good job, and I will see you next class.